So, this is Her Majesty Easy World Science Channel, and I'm your friend from Nigeria here, friend to the Indians. So today I'll just introduce revision class for the National Eligibility Entrance Test, that's NEET. I'll be taking you guys in chemistry and biology. Out of the 180 questions at least, when I take you chemistry and biology, they are short of about half. Okay, only physics is what I will be handling. So out of the 100 questions in biology, when you work with me, Her Majesty, you will score not less than 80 of them correctly and avoid negative marking. Then out of the 45 questions in chemistry, when we follow on for the 2021 NEET exam, I'm sure you will get not less than 40 over 45. So this is just the intro, and I'll be doing it in combination with Joint Admission and Matriculation Board exam here in Nigeria. So I will take a look at a few questions for that of NEET exam 2018, just two. Then subsequently I will handle the other ones. This question here is about calculation. You see the question there on the screen. It says a mixture of 2.3 grams. That should be NEET question 57 and 58. I'll take the two and just to tell you what I can do. So question 57 says a mixture of 2.3 grams of formic acid and 4.5 grams of oxalic acid is treated with conc H2SO4. The evolved gaseous mixture is passed through potassium hydroxide pellets. Weight in grams of the remaining product at STP will be, you see the question there on the screen. So we are handling actually NEET questions and answers. So this time around, from the question number 57 and 58, they gave us 2.3 grams of formic acid, and then what mass of 4.5 grams of oxalic acid. So these are the thing, and the reactant here is actually H2SO4 against each of them concentrated. First, this is a calculation actually, but you are required to know what formic acid is and oxalic acid is. I'm not teaching you to get the answer. I'm teaching you this only so that when you have a related question, you can also solve it simple. So formic acid is actually called methanoic acid. In that case, it is actually having the formula of HCOOH. That is for methanoic acid. While oxalic acid is called ethane 1,2-dioic acid, ethane 1,2, which means it is a dicarboxylic acid. So this one is called, this is formic acid, and this is called ethane dioic acid, or ethane 1,2-dioic acid. Dioic acid. So then, reacting each of them with conc H2SO4, you should bear in mind that carbon is 12, hydrogen is 1, oxygen is 16, which will enable us the calculation of the molar masses. So in that case, you are just acting if you know how to produce the two gases in the lab. These two particular things, formic acid and oxalic acid, remember they are all solids, is just raw material for the production of the two gases, carbon 4 oxide and carbon 2 oxide. So if you treat the first one here, by structural formula we have this double bond OH. This is actually formic acid. Then action of conc H2SO4 to it. We just minus water from it. So this H2SO4 is acting as a dehydrating agent. It will dehydrate formic acid to produce only but CO. So H2O, let's eliminate the H2O, meaning removing 2 hydrogen and 1 oxygen. So what we have here is actually HCOOH. So remove this OH and this H, that is H2 and 1 O, that's remove this and this. So what is left behind is only carbon 2 oxide. So in that case, from the equation here on the board, you discover that you discover that 1 mole of formic acid, when it's dehydrated, gives us 1 mole of CO2 at STP. When they say STP there, they are talking about volume, of course, but I think the question says a mass. So the volume is not actually much of a business now. So we take the molar mass. Hydrogen is 1. Molar mass of formic acid, 1 plus 12 for this carbon, plus 16 for this oxygen, then plus 16 again for this oxygen, plus 1. So what we have here, we have 13 plus 32 plus 1, such that we have 13 plus 33. What do we have here? 46. Okay, we have 46. Thank you. So 46 is the molar mass of formic acid, which means 1 mole of this is charged. So we have that 46 grams of this acid, HCOOH, will produce 1 mole of CO, and carbon is 12. 12 plus 16 is 28. So we have that 46 grams of this will give us 28 grams. Then from the question, they give us 2.3. So if 46 can give you 28 grams, what will 2.3 produce? Okay, let me maybe try pressing with a little phone here. I didn't know in order to come with that. So we have 28 divided by 46 times 2.3, which will give you 1.399, which is actually 1.4. This will give us 1.399, approximately 1.4 grams. So what we have is 1.4 grams of CO is the gas produced when you treat 2.3 grams of formic acid with conc H2SO4. This is fact 1. This is our fact 1. Then second fact from the question is, we have another acid here, which is oxalic acid. So this is oxalic acid actually. On treating it with conc H2SO4, it will still eliminate water. So the water eliminated here is simple. You can take it this way. So this is H2O has gone. So that what is left now is CO plus CO2. So these two gases are produced, these two gaseous mixtures are produced on treating oxalic acid with conc H2SO4, unlike formic acid. Now, from this, we take the molar mass. I think this should be 45. That's carbon is 12 for the first one, plus 16 plus 1. What do we have here from the calculator department? Okay, 16 times 2, please. For this COOH, 12 plus 32 plus, which is still 40 what? 45, right? So we have 45 times 2 because it's 2, which is 90 grams. So the molar mass of oxalic acid is equal to 90 grams. Then from the question, 1 mole of CO2 and 1 mole of CO are all produced from it. But since they say that the gaseous mixture was passed through KOH, note this. Almost all the alkalis have the quality of removing carbon dioxide from a mixture of gas. So you can use this or this to remove CO2. Now, since they say that the gaseous mixture is passed over KOH, it means that CO2 has been removed. So the remaining gas will no longer contain CO2, rather it contains only carbon dioxide, that's CO. So from the equation, you can now see that 1 mole of oxalic acid will give us 1 mole of CO and also CO2, but this has removed CO2, so this is no more considered. Then change it to mass. 1 mole is 90 grams. 90 grams of oxalic acid, which is which is actually C2H2O4. C2H2O4, yeah, of course. We now give you, convert this to mass again. 1 mole of this is 28 grams. Of course. So we have 28 grams in the sense that we have 12 plus 16, 2 and this 8, then we have 28 grams. Then go back to the question. Since 90 grams of this acid on treating it with conc H2O4 give us 28 grams, what will 4.5 grams of C2H2O4 give us? We call here X, cross multiply, such that we have 28 over 90 times 4.5 over 1. I think it's taking us almost to the same point like this. What's the answer?
What's the question?
28 over 90 times 4.5.
1.4.
1.4. Of course, give us 1.4 grams of CO2. So, you add up these two. So, from treating it with conc H2O4, we have 1.4 grams of not CO2. Then, on treating it with formic acid, we have 1.4 grams only. So the answer is now 1.4 plus 1.4, which is 2.8 grams. Final answer. This is the answer to the question. You see there on the board. The answer to the question is 2.8 grams. So in exam, you should memorize that oxalic acid is 90 grams, formic acid is 46 grams as the molar mass. So don't get confused here. They are just, the main aim for this question is to check if you are aware of what will happen when you treat formic acid in conc H2O4. What happens? Carbon 2 oxide is liberated. So laboratory preparation of carbon 2 oxide involves dehydrating formic acid with conc H2O4. Or if you also want to get the two mixture of gases, oxalic acid on treating it with conc H2O4 will remove water. Remember, H2O4 in any reaction in chemistry has 3 functions. It is either acting as an acid, where it is neutralizing a base to form salt and water, or it's acting as a dehydrating agent, where it is removing water molecule. In this reaction, conc H2O4 is the dehydrating agent, or rather, it is acting as an oxidizing agent. But before conc H2O4, that's before H2SO4, that's sulfuric acid, will act as an oxidizing agent. It must be concentrated and hot. Dilute ones and cold ones are not usually oxidizing in nature. So 3 things that the acid can play the role of in any chemical equation. That H2SO4 can stand as an acid where it neutralizes a base to form salt and water. Then it can also stand as a dehydrating agent, as you can see here, to remove water molecule. Or rather, it can stand as an oxidizing agent. Okay, so in this equation, they are testing if you know actually that conc H2SO4 is a dehydrating agent, and its corrosive effect is due to its dehydration ability. When it comes in contact with your skin, it burns your skin by removing water molecules from it. So it is acting just like an open fire, because it is quickly removing water from you, thereby cleaning your cells. So when the corrosive nature and the harmful effect of the acid on organic matter is due to its strong dehydrating ability that gives this burning sensation. You can watch other videos to see where conc H2O4 I used it to carry out some dangerous reactions, reacting it with our table sugar. It gave us a black sugar snake, very dangerous. That is how to produce sugar charcoal. Even when I treated watermelon with conc H2O4, these are all organic compounds. So you have your questions there that you are participating in this exam. Any question concerning NEET, I promised you I will handle them very well. And those topics will be treated well, but it depends on you guys. But I know you have been there for me, Some Majesty. So I love you guys and I want to help you guys pass the exam. So the next question I promised to answer 57 and 58. Let me see what the next question says. Okay. Question 58. As you can see there on the screen, is saying, that's after 57, said which of the following oxides is the most acidic in nature? Okay, maybe let me write it because it's short. Which of the following oxides is the most acidic in nature? I think their options are option A, option 1 is barium oxide, option 2 beryllium oxide, option 3 magnesium oxide, option 4 calcium oxide. Okay, this is all about, the question is simple, but what you have to know is, first, metallic oxides are actually basic oxides. Metallic oxides are actually basic oxides. And all these oxides, option 1 to 4, are all metallic oxides. So, why are they asking you acidic in nature in terms of basic oxides? Oxides of metals are basic oxides. Why? Because they react with water to form alkalis, some of them. Or that some of them react with acids to form salt and water. So all these things, let's assume you react magnesium oxide with HCl. This magnesium oxide will act as an acid because what will be formed is simple salt and water. And as we all know, whatever that will react with an acid to form salt and water is a base. Now, beryllium, magnesium, calcium have one thing that connects them. What connects them? They are all group 2 elements. They are all group 2 elements. Group 2 elements. Then, for you to get this question well, you have to arrange them according to the order from period 2 down to period, I think period 6 or 5 there. So, we have this. You can really say the acronym be majestic, can skills be real. Sit down, but be majestic, can skills be real. That's how to arrange it in this group 2, which means beryllium, magnesium, calcium, strontium, barium, and radium. You can also do yourself a favor by watching my video here on this channel on how to fill the periodic table by yourself. The songs to fill the whole periodic table, the whole elements ever, including the F block elements, the D block elements. So you have seen how to get your group 2 element, otherwise known as alkali earth metal. So beryllium, magnesium, calcium, strontium, barium, radium. This is their order of arrangement. First, we should check their basic nature. Their reactivity will also determine their basic nature, the basic nature of their oxide. If you move down here, it means an increase in reactivity, an increase in electropositivity, and also an increase in reactivity. Which means among all these, beryllium is the least reactive. Then it shows also that the nature of their oxides, when you go down here, nature of their oxides, because metallic properties, the metallic property also increases down the group. Metallic property increases down the group. And one of the metallic properties is that they form basic oxides. So one of the metallic properties is that they form basic oxides. So nature of their oxides is this. It is assumed that all of them are basic oxides. But when you go down here, the oxide of radium is more basic than the oxide of barium. The oxide of barium is more basic than that of strontium. So this one should be the least basic. And hence is the least basic. It shows that it's the most acidic. So in that aspect, it shows that this is the correct answer from the arrangement. The nature of their oxides, what happens? Increases, the basicity increases down the nature of their oxide, they increase in basic nature. That's, how do I put it? Basic characters increases also down the group, because radium is more metallic than barium. So the oxide of radium is more basic than that of barium. So in that sense now, this is beryllium oxide is the least basic, while radium oxide is the most basic. So, which is followed by barium oxide. So the other one is now strontium oxide, the other one is calcium oxide, magnesium oxide. So if you are to arrange them in basicity, beryllium oxide is less basic. Okay, let me get it this way. When you move down here, it means increase in basic nature, increase in basic properties. Increase in basic properties. Then, which is equivalent to decrease in acidic properties. So, which means radium oxide is less acidic than barium. It's so-called. So, this one is the most acidic. So, if you move from barium oxide down to radium oxide, you find out that acidity decreases and basicity increases. That's basic properties increases, but acidic properties decreases. So the correct answer is barium oxide. After barium oxide, what follows is magnesium oxide. Then after magnesium in acidic property is calcium oxide. Then the least acidic, if they change this now from most to least, which of them is the least acidic? You say barium oxide, considering this. Then if the question is reconstructed by telling you which of them is the most basic, if this acidic is changed to basic, the answer is still barium. Then if here becomes the least basic is still barium oxide, considering this. Just know that be majestic and skills be real shows the correct arrangement of the two elements. And when you move down the group, there is an increase in electropositivity and also increase in metallic property. It's in the nature of metals to form basic oxide. The more metallic you are, the stronger your oxide is basic. So the less metallic you are, the less basic your oxide is. And less basic means more acidic. So beryllium oxide is the correct answer to this question. God bless you. See you in the next series of the NEET questions and answers. Subscribe, share, and let your friends know of this.